Greetings to all Naicol Land scientific research personnel. Today, we'll be demonstrating the elephant toothpaste reaction using hydrogen peroxide and potassium iodide. Before we begin the experiment, we'll briefly explain the chemistry behind the reaction. Hydrogen peroxide naturally decomposes into water and oxygen gas, but this reaction normally happens slowly. Potassium iodide acts as a catalyst and speeds up the decomposition process. As oxygen gas is produced rapidly, dish soap traps the gas bubbles and creates the large amount of foam seen in the reaction. For this experiment, we will require ingredients such as potassium iodide, hydrogen peroxide, dish soap, food coloring, and distilled water. The equipment required for this experiment includes an Erlenmeyer flask, measuring cylinders, a beaker, a funnel, a stirring rod, and a weighing scale. Hold up for a second there. Safety is very important during this experiment. We are using concentrated hydrogen peroxide, which can cause irritation or burns if handled incorrectly. Moving on to the procedure. First of all, prepare the potassium iodide, or Ki solution. Second of all, prepare the base solution. And finally,
get ready.
You know what? Like, actually, you should stand here.
Work on your dress.
in order to stay safe, safety goggles, gloves, and lab coats must be worn at all times. The reaction also releases heat, causing the container and foam to become warm. Before starting the demonstration, all chemicals and equipment were prepared carefully. Hydrogen peroxide, dish soap, and food coloring were added into the measuring cylinder first. The potassium iodide solution was prepared separately before being added as the catalyst.
Yeah, hang on, Randy. I'm getting this laptop up. This thing is taking ages.
Yeah, we are recording this part right now. Okay,
Warning, the following section contains restricted chemical equation data. Level 3 access required, proceeding to analysis. The demonstration uses this reaction shown in the equation below as the primary trigger. Hydrogen peroxide is an unstable chemical and can quickly decompose, creating oxygen gas. By using Ki, the iodide ions bind with the unstable oxygen atoms in hydrogen peroxide, allowing oxygen to be released faster and causes quick gas production, driving the whole experiment. This reaction is also an exothermic reaction, exothermic meaning releasing heat. This is because more energy is released when new bonds form in water and oxygen molecules than that to break the bonds in hydrogen peroxide molecules. The excess energy is released as heat, which is why the foam gets hot after the reaction.
Exit code 12. Central boots up. Commencing now.
Optic relays are online, sir.
Resident Engine A online.
Engine B is up.
Very well. Perform the experiment.
Dentra is ready for deployment, sir.
Perfect. Code 5, commencing Centra data analysis procedure.
As we've stated before, the chemicals used are not safe for humans and living things in general, so throwing those out like regular garbage definitely isn't the best idea. If working within or near a laboratory, dispose the chemicals in the appropriate location, such as a labeled garbage bin. If working externally, consult help regarding chemical handling to ensure long-term safety in the process of disposal. And of course, remember not to expose yourself to the chemicals in any way by wearing protective clothes and equipment. This concludes our demonstration for today.
Oh, Naicol Land, I still remember you. The lights across the empty hall, the little things we used to do.
We thought the days would never end, that we would all grow. But now your halls are silent, and the air feels cold.